Good afternoon, class. We are looking at the second part of the practice test for the first module. We are asked to perform the indicated operation and express the result as a simplified complex number. So first and foremost, what do we mean by complex number? I'm going to remind you that a complex number is in the form of a plus bi. I by definition is square root of -1. Therefore, square root of negative n would be I square root of n. Sometimes they put the I in front because we don't want to, make a mistake of thinking it's under the radical. And when we multiply these two, becomes a squared plus b squared. So I'm going to remind you as to why it happens. Recall that a minus b times a plus b is a squared minus b squared. So if we have a minus bi times a plus bi is a squared minus b squared I squared. So we need to know that I squared is -1. Therefore, it becomes a squared plus b squared. So just wanted to remind you of that. And now we are going to multiply the two parentheses by simply distributing. So we're going to distribute, which means I'm going to multiply -1 by -2. I get +2. -1 times 3i is -3i. 2i and -2. -4i, 2i, and 3i is 6i squared. You would multiply it as though I is x. That's the first thing you do. Now you will figure out what you have to do here by going over this process. I by definition is square root of -1. I squared is -1. I cubed is I times I squared. Since I squared is -1 becomes -I. And I to the power of 4 is I squared to the second power makes this positive. Since we know that, we are going to change this I squared to -1. And when we multiply by +6 becomes -6. And now we can combine number 2 and number 6 into -4 and combine the like terms, -3i and -4i into -7i. And this is in the form of a plus bi. So if somebody asks, what is a? -4. What is b? -7. Part B, if somebody says divide, rationalize, or put it in standard form of a complex number, meaning a plus b and I, it means the same thing. The technique is to multiply by complex conjugate of the denominator. Again, I did mention a minus b. The conjugate of a minus b is a plus b, which results in a squared minus b squared. The conjugate for 2 minus I is 2 plus I. So we're going to multiply and divide by it. And it is important to know this expression is equal to 1, so we can do that. And so multiplication of the top, we just distribute, we FOIL, if you will. So 3 and 2, that's 6, 3i, 8i, 4i squared, and this is 2 squared plus 1 squared. I'm using this one. I squared is -1 with plus 4. That gives us -4, -4 with 6, +2. We add this 2 into 11i, and we get 5 in the denominator. Now, if we leave it like so, it's fine as long as we can recognize the value for A and for B. The reason I'm going to separate them into this format so we can clearly say A is 2/5 and B is positive 11/5. What if we want to add these two? First, we have to get rid of the negative under the radical, and that is represented by I, and 9 becomes 3, so this is 3i. Negative is represented by I, and 16 becomes 4. This is 12i, and the final answer is 15i. I to the power of -6, we can write it as 1 over I to the power of 6. And now, how do we simplify this? I to the power of 4 is 1. So all you have to do, anytime the number, the exponent here is larger than 4, divide by 4 and just keep the remainder. So I'm going to show you. If I divide this 6 by 4, the answer is 1, and the remainder is 2. This is what matters. So it's 1 over I squared, and we know I squared is -1. This ratio is -1. To make sure we understand what's going on, I'd like to give you a couple more examples.
I have a question.
Sure.
Is there any reason why you're taking -6 divided by 4?
I had a hard time hearing. Would you repeat that, please?
I was just wondering why you did +6 divided by 4 instead of -6.
We are dividing +6 by 4.
I was looking at
And
I
it,
times
yeah, and it gives us 1 with the remainder 2. I'm going to look at more examples. You'll see what I mean in a moment.
Okay, thank you.
I want to look at this one. So I'm going to divide 12/25 by 4. The quotient is not important. What matters is the remainder. And the remainder is 1. How do we know that? A number is divisible by 4 if the last 2 digits would be divisible by 4. 24 is divisible by 4. Therefore, 12/24 is divisible by 4. The remainder becomes 1. So this is I to the power of 1, which is I. Again, just to make sure everybody understands, I'm going to give you one more example. I to the power of 43. I'm going to divide 43 by 4. And again, I'm just interested in the remainder. You know 40 is divisible by 4, so the remainder is 3. Therefore, I to the power of 43 is the same as I cubed. And I cubed, we should know it's -1. That's why I gave you this. We must know that I cubed is negative I. I put negative I, didn't I? It's negative I. I cubed is negative I. All right, so that's how you deal with powers of I. Square root property. If x squared is a, then x is plus minus square root of a. For example, x squared equals 49, x is plus minus 7. We can solve the quadratic equation by completing the square. So we need to know what is a perfect square. A perfect square trinomial is a trinomial that can be expressed as the square of binomials. For example, x squared minus 10x plus 25 is x minus 5 squared. And note that in every perfect square trinomial, the constant term, this number, because this is a equals 1, b equals negative 10, and c is 25. The constant term is the square of 1/2 of the coefficient of the x term, or b over 2a. In this case, whenever we want to solve that, we keep a at 1. So when you divide this 1 by 2, you get negative 5. When you square it, you get 25. So we write this in this format by moving the constant and making sure we divide both sides by a. And then we divide b by 2. And if we add b over 2 squared to both sides, the left side becomes x plus b over 2 squared. And the square root principle can be used here, simplified, solved by the square root principle. The quadratic formula, everybody remembers, it was for the case of ax squared plus bx plus c equal to 0, x is minus b, plus minus the square root of b squared minus 4ac over 2a. What's underneath the square root is called the discriminant because it gives us a lot of information. If it's positive, you have two distinct real solutions. If it's 0, you have one real solution. It repeats. And if it's negative, you have no real solutions. We have two complex solutions. In addition to that, the solution will be rational if the discriminant is a perfect square and irrational otherwise. And in that case, we can factor. If it's 0, we have one real solution. They call it double root. And in this case, there is no real solutions, two complex solutions. Let's look at a couple of examples involving completing this square. There are a couple of things we want to do. We want to make sure that we move the constant, and we want to make sure a is 1. So all we have to do, move the constant 7. We notice b is given as 6. We divide it by 2, becomes 3. We square it, becomes 9. So you write the value of b, you divide it by 2, you square it, and you get 9. We can add this number to both sides now. And here's what's going to happen on the left side. The left side will always be x, or any variable that you're dealing with, plus b over 2. Now, if b over 2 happen to have a negative sign, then you keep the negative sign. So plus b over 2. Whatever the sign has, you keep it. So the left side, therefore, will be x plus 3 squared. But the right side, they add up to positive 2. Now you can use the square root property, saying x plus 3 is plus minus square root of 2. move the 3, that means subtract, and this is your final answer. Now, again, I want you to notice two things. Number one, we have two answers here. You can leave it like that. Or you can say -3 minus square root of 2. And here's the second equation, -3 plus square root. And both of them are exact. If you want an approximation, you can use a calculator. Square root of 2 is about 1.41, and then you can come up with an approximation. But this is an exact answer. You probably want to keep it as such. What about this one? Well, we're going to move the constant first. Then it's easy to get rid of the a. That makes it easier. So how do you get rid of the a? You divide everything by 2. And so what happens next? B is -7/2. You divide it by 2, you get -7/4. When you divide a fraction by 2, you can multiply the denominator by 2. This is very basic. So divide this number by 2, you get -7/4. You square that, you get +49/16. So one more time. Here's the value of b divided by 2. Square it. Now add this number to both sides. So what happens on the left side again, you simply put the variable, in this case is z, not x. So you put z plus b over 2. What is b over 2? -7/4. So z plus -7/4, that means z minus 7/4. So the left side is very obvious. What about the right side? Add these two, because the denominator is 16. We're going to change the 2 to 32 over 16. So 32 and 49, they give us 81. Left side becomes z minus 7/4. The right side becomes plus minus the square root of 81 over 16, which is 9 over 4. We are moving the -7/4 to the right, becomes +7/4. If we add up 7 and 9, 16 over 4 gives us 4. If we subtract 7 minus 9 is -2 over 4, or -1/2. So I hope you can go from here to here. So 7 over 9, 7 over 4, 9 over 4 is 16 over 4, or 4. 7 over 9 minus 7 over 4 minus 9 over 4 is -2 over 4, which is -1/2, -1/2. So solve by completing this square. We're going to move on to the quadratic formula. We have the formula for you here. And to use that, we have to put it in standard form, meaning we're going to move the 5. In which case, A is 2, B is 4, C is negative 5. We are going to plug in everything into the quadratic formula. When we do that, we get 16 plus 40 here, 56, and 56 is the product of 4 and 14. 4 comes out as 2. Now here's what you want to be very careful of. You can't drop the 4 in the denominator and say this changes to -1, because that's a mistake sometimes students make. No, you have to take common factor out. So if we factor the numerator as a 2 times -2 plus minus the square root of 14, now we can do it like so, and we are done. Part B is in the form we need. All we have to recognize would be the value of A is 7, B is 4, C is 3. And now we're going to put this into the formula. Replace the B with 4, the A with 7, the C with 3, so on and so forth. So we are going to do that. And we need to simplify. Four squared is 16. Minus 4 times 7 times 3. 84. So 16 minus 84 is negative 68, which is the product of -1, 4, and 17. So what happens? -1 is represented by I, 4 is represented by 2. Sometimes they put the I in between because they want to make sure it's clear that it's not under the radical. Otherwise, it's completely wrong. And just as we did here, we factor the 2 out. And this is the final answer. Now, part C clearly is not a quadratic, can be done, a quadratic equation. It can't be done by a quadratic formula the way it's given. But one way is to multiply the top and the bottom by x squared. When we do that, the right side is 0 and it doesn't change. Just x squared is fine. This gives you 2x squared. The reason it's fine because you're multiplying both sides by x squared. When you multiply these two, you get 4x. When you multiply these two, you get -1. And now you can use the quadratic formula. So you're not multiplying by x squared over x squared, you're multiplying by x squared only. And A is 2, B is 4, C is negative 1. We're going to put that again into the quadratic formula. We're going to plug in. Four squared is 16. Minus 4 times 2 times negative 1 is plus 8. We get 24. 24 is the product of 4 and 6. 4 comes out as 2. Factor out the 2. And this is the final answer. What I want to make sure everybody understand, this is the final answer and it's fine. But if you wrote it in this format, meaning you're making up two fractions, and again, we can't just drop the 2 and 2 here. This is negative 2 over 2, which is negative 1, and this one remains intact. Again, what you're looking at is the exact answer, everybody. What you're looking at is the exact answer. Approximation, you plug it into a calculator and approximate it. So let me just move on to the next question. We are solving an absolute value equation. So number one, isolate the absolute value so that the equation is in the form of absolute value of x plus b equals c. If c is negative, if this side is negative, there is no solution because we are saying absolute value is equal to negative. And remember, absolute value is distance from 0. Worst case scenario, it can be 0, but it can never be negative. If it's positive, then we can make up two equations. We drop the absolute value and we say x plus b is c, x plus b is minus c, and we solve that. So what I want to remind you is the definition of an absolute value, which is distance from 0. It's x if x is larger than or equal to 0, and it's negative x if x is less than 0. With that being the case, 4x minus 7, we can drop it and say it's equal to 5 or negative 5, so we can say it in one shot plus minus 5. We're going to move the negative 7 becomes a positive 7. We can divide both sides by 4 to get to x. Now, because we can combine, we must, otherwise we are done. So when we combine 7 and 5, we get 12 over 4, which is 3. When we combine 7 and negative 5, we get 2 over 4, which is 1/2. So I want to make sure we understand what happened here. So 7 minus 5 over 4 gives you this number. 7 plus 5 over 4 gives you this number. Now, the next one, remember the first step is isolation. Therefore, we must move the positive 1. Becomes negative 1 and 3 becomes 2. Now that it's completely isolated, 2x minus 5 is plus minus 2. We move the negative 5. We divide by 2. And again, we can combine them into 5 minus 2 over 2, or 5 plus 2 over 2, which results in 3 halves as well as 7 halves. We're going to solve the absolute value inequality, and the methodology is: number one, you isolate. After you isolate, if the absolute value is less than a and a is a positive value, then you sandwich that between negative and positive. And if it happened to be negative, there is no solution because absolute value can't be less than a negative number. In this case, when it's larger than a and a is positive, then x is less than minus a, or x is larger than a. For now, let's look at this one. The very first step is isolation. There's nothing to do, just the way it is, it's fine. We're going to drop the absolute value and sandwich it between positive and negative 7. So it's negative 7 goes to this side, and we have the following. We are going to get rid of the 3. We're going to divide everything by 2. So we get x between negative 5 and positive 2. Here's the interval format. If they ask for the graph on a number line, you have the number line, and you go from negative 5 to 2 at negative 5 as well as 2. We either use parentheses or we put a hole because the endpoints are not included because the equality is not there. So either you use a hole there and you combine, connect them, so there's a hole on each side, or you use parentheses. Don't mix and match because the endpoints are not included because we have only less than. In this case, we have a greater than situation, and the first step is to isolate. The next step is to divide both sides by 2. And now that it's completely isolated, then we are going to follow this. So 3x minus 1 is less than or equal to negative 5, or greater than or equal to 5. In other words, pay attention to this step and how we go from here to here. Now each one must be solved. We are going to add 1 in each case. This is what we get. We are going to divide everything by 3. And this is the final inequality answer. So we solved it. We want the interval notation. X is less than or equal to negative 4/3. That means from negative infinity to negative 4/3, or we use a union of events, and x is larger than or equal to 2, from 2 to infinity, because the endpoints are included, we use parentheses here. So here's the interval format. Negative 4 is included, yes. Because of the equality, we use bracket. Is 2 included? Yes. Because of the equality, we use the bracket. So this is the interval format. Now on a number line, we are going to pinpoint negative 4/3, which is negative 1 and 1/3. So this is negative 1. It's between these two, and somewhere here is negative 4/3. And we either put a bracket or a solid point and to the left. And then we locate 2 here, solid point or bracket to the right. Again, you could use solid point, rather, or go this way. That's how you can do that. All right. How about this one? Isolate first. Notice we are saying the absolute value is less than or equal to a negative number. This will never happen because absolute value in the worst case scenario is equal to 0. So this has no solutions. No solutions. I'm going to solve a radical or root equation. Again, the very first step is isolation. You're going to move the 7. So that means we're going to subtract. The next thing is to raise both sides to an appropriate power. Because the left side is a square root, we are going to square it. And so we're going to square both sides. The left side comes out. Now the right side is x squared minus 14x plus 49. I hope you remember that. Because sadly, sometimes students miss the middle term of negative 14x. You want to solve this? This is a quadratic equation. We're going to put it in standard form by bringing everything to the same side. So minus 2x minus 1. We want two numbers. The product is 48. And the sum is b or negative 16. Negative 4 and negative 12 are the answers, and we have two answers, 4 and 12. However, you must check. Checking takes place only with the original equation and nothing in between. So we go here, we plug in 4. When we are done, we plug in 12 and check it. So if I plug in 4, I want to see if they are equal. Notice this is 2 times 4, 8 plus 1 is 9. And this is 3 plus 7 Is 10 equal 4? No, that's not a solution. So x equals 4 is not a solution. What happens is that in the process, we created that, which is called an extraneous solution. Meaning an extra solution, which was found mid steps, but it will not work with the original equation. Now, the original equation, we are going to put number 12. 2 times 12, 24 and 1, 25. So you have square root of 25, which is 5, plus 7 is equal to 12. Yes, that's an acceptable answer. You're done. All right, we want to solve this. First, let's square the left side. We get x squared plus 4x plus 4. And the right side, by now we should know, this is x squared, then minus 1 and minus 6 minus 7x, and then their product is positive 6. I'm assuming we can do this. We can FOIL this pretty fast. Again, I'm going to repeat. This is for the sake of the reverse process, which is factoring. If you want to multiply these two, x times x is x squared. Then you add these two numbers, negative 1 and negative 6 is negative 7 times x. And then you multiply these two, you get positive 6. Now, let's bring everything to the same side by doing the following. X squared and x squared, you don't have to move them. They are identical. And so they cancel each other. Let's move the negative 7x. And let's move the 4. We get 11x equals 2. And we are done. How about this one? What is the methodology? It's important to understand when we raise it to the power of fraction, 5 there's, that means we are raising it to the power of 5, and we are taking the cube root at the same time. So to undo this in one shot, the best course of action, to raise both sides to a power which will undo this exponent. And that would be raising it to the power of its reciprocal, which is 3/5. So if we raise both sides to the power of 3/5, the left side becomes a 4x plus 1. So this comes out as 4x plus 1. Now, 32 to the power of 3/5 needs to be discussed. I hope you remember this is the 5th root of 32 to the power of 3. In other words, what I want to show you and remind you is the following. A to the power of m over n, we can write it as nth root of a to the power of m, or we can write it as nth root of a to the power of m. And that's exactly what we are doing because it makes it easier to do it that way. So the 5th root of 32 is 2 because 2 to the power of 5 is 32. When you cube number 2, 2 cubed with that gives you 8. And so 4x equals 7 divided by 4. And this is your final answer. Now, for a case like this, part A, I can raise this to power of 2, multiply by 2, combine and do the math. However, I notice this is 3x minus 4, so is this one. So if I use substitution, it's a lot easier. And I let 3x minus 4 be any variable except x. So you can choose y, z, m, who cares? So let y represent 3x minus 4. Then you have 2y squared plus y minus 1. And there are different methods to solve this. Factoring will do the job. Remember, 2 is a prime number, so it's easy to say 2 is 1 and 2. You can say 1y and then 2y. And since this is 1, you have no choice but to put 1 there, one of them negative, one of them positive. So you can put negative 1 here, positive 1 here, and see that whether the middle term works. This is negative 2y plus y, and that gives you negative y, so that doesn't work. So what do? You put plus 1 here and minus 1 here, and it does work. Okay. Therefore, y is either negative 1 or 1/2. Okay. But we haven't finished the job because we are interested in x, so we have to set this one equal to negative 1 and 1/2 and solve. So we move the 4. Three x equals 3. We move the 4. 3x equals 4.5, which is 9/2. Now, if you divide both sides by 3, this gives you 1. This gives you 3/2. I'm assuming we have no problem with fractions. And you can always check with the original equation. For part B, we do substitution by letting x to the power of 1/3 be anything except x. For example, m. And when you do that, this is m squared equals 2m plus 3. We move everything to the same side and we factor. We factor it into m minus 3m plus 1. So m is either 3 or negative 1. But we are interested in x. And to solve for x, notice what's going to happen. If I raise to the power of 3 here and raise to the power of 3 here, I get x equals m cubed. Therefore, the answer is to cube this number, which gives you 27, cube this number, which is still negative 1. Notice I didn't say cube root, just 3 cubed 27 minus 1 cubed. So this is 3 cubed. This is negative 1 cubed. And it's really a good practice to check, as always. with the original equation. Nothing in between, always the original equation. All right, we are going to continue with either substitution or just the way it is. First and foremost, for part A, I'm going to move negative 15 and make it positive 15 on the other side. The second is, if I want to use factoring just the way it is, please understand that r squared times r squared is r to the power of 4. If that's not good enough, you can always let r squared be anything, for example, x, and this becomes x squared minus 8x plus 15 equal to 0, and factor it into x minus 3, x minus 5, or just do it right here, r squared minus 3, r squared minus 5. It is your choice. I think it's simple enough. You don't have to do a substitution, in which case r squared is either 3 or 5. If you put it here, x is 3, and then you have to write this one, x is 5, then you have to write this, and r is plus minus the square root of 3 plus minus the square root of 5. You have the equality. Part B, there are two ways. You can let b to the power of negative 1bx, or y, or z, or m, or u, any variable except b. Then the first one becomes 6x squared. The next one becomes minus 5x. You can go this route, or you can multiply both sides by b squared, and you can solve it that way. Either way is fine. And this is a simple factoring because 6 is either 1 times 6 or 2 times 3, and 1 is simply 1 times 1, both of them having the same sign. And so it's a trial and error. There are other methods, 2x minus 1 times 3x minus 1. I've gone through the process for you. So x is either 1/2 or 1/3. Now, it is important to understand the meaning of this. X is b to the power of negative 1 means 1 over b is x. That means b and x are reciprocal of each other, or you can say b is 1 over x. So the reciprocal of the two numbers, 2 and 3, are what we are looking for. A fitness club charges $20 as a monthly access fee and $2 per day of use. Express the monthly cost C in terms of daily usage. Well, if they charge us $2 per day, if we use 1 day, it's 20 plus 2. 2 days would be 20 plus 2 times 2. 10 would be 20 plus 10 times 2. So if we let x be the number of days, it will be 20 plus 2 times x. So the cost is 2x plus 20. And if we use it for 15 days, we replace the x with 15. $30 and 20, they add up to $50. Then for that month, our cost will be $50. box. If the length of a rectangle is twice its width and its perimeter is 90 meters, find the dimensions. Well, if this is the width, this is the length, and the length is 2 times W, we know that the perimeter is 2 times L plus 2 times W, or 2 times L plus W. So the given is L is 2W and P, which is 2L plus 2W, is 90. By the way, again, this formula, I could have said 2 times L plus W. Either way is fine. If I replace the L with 2W, then 2 times that would give me 4W. I will combine the 4 and 2 to 6W. When it divide and the width becomes 15, I always use the given units, proper units, 15 meters, and the length is twice that, 30 meters. The length is twice that.